Okay, anyways, like I was saying, guys, basically what we're doing today is we're going to go through quick revisions for the previous two chapters. And after that, we're going to be doing some exercises together. Then we're going to be doing a little experiment in the center. So for those who are online, you will be forced to just continue doing the exercises. Okay, so anyways, starting from the first chapter, the first few formulas we have learned, even before the formulas we learned about scalars and vectors, right? Can anyone tell me what's the difference between a scalar and a vector again, without referring to your notes, Macy?
Vector has magnitude.
Good, it has magnitude, whereas vectors have magnitude and
Direction.
Direction. Excellent job, Lucas. Right. So from here, the first difference we learned is scalars and vectors, right? And then I gave you examples of scalars and vectors. Scalars is basically the most common example, which is distance law, right? Distance does not care about direction because your distance could have been A to B to C to D to E or whatever. It has no one specific direction. But displacement, which is a vector quantity, displacement, which is a vector quantity here, takes into consideration not only the magnitude, but also the direction. And like I mentioned in the first class, displacement is always the starting position to the ending position in one specific direction here, right? This is what we talked about in terms of distance and displacement. Once we understood distance and displacement, we were able to formulate the two speed formulas, right? So if we talk about in terms of speed, guys, what's the formula for speed again, Macy? Good, it is distance over time. And velocity would have been, what's the formula, Neunica? What's the formula for velocity again? Neunica, what's the formula for velocity? Good, it is displacement over time. Excellent. Both of them are going to indicate how fast an object is moving, right? For example, speed is meters per second and velocity is also meters per second. Then finally, the last formula that we learned about before we went into our motion time graphs is basically acceleration, right? What's the formula for acceleration again, Lucas?
Speed over time.
No, not just speed over time. This is the final what?
Oh, sorry. Final acceleration minus initial velocity. Final velocity minus initial velocity over time.
Yes, excellent. Right. This was the formula is final minus initial over time. And what were the units again, Macy, for acceleration?
km.
Okay, let's solve it one by one. Now, what's the units for velocity again? And what's the units for time again? And thus acceleration's unit will be in meter. Nani, measure. Measure or not? Wait, meters per second divided by second, right? Yeah, it's meters per second square. Macy, remember these are the basic things, right? Now, with these formulas in mind, we basically moved on to the next part, which was the motion time graphs, right? Starting off with the first motion time graph is essentially the distance time graph here. Let's imagine this is the distance axis and this is the time axis. Now, I mentioned that in the graphs, we always extract information based on two things. What are the two things again, Lucas? What are the two things that we look at in the graph again?
Line.
Line. No, not a line. Starts with a G. What's the G? Huh? Good. It is the gradient, right? And then the second one was starts with an A. What?
area.
Area under the graph. Guys, very important now. Pay attention when I keep saying this. Whenever we have graphs, not only in physics, even in mathematics, the gradient is always supposed to tell you information, right? Because the gradient mathematically is change in y-axis over change in x-axis, right? Your y2 minus y1 over x2 minus x1, right? In this case here, your y-axis is your distance and your x-axis is your time. In other words, the gradient is supposed to tell you the speed, Nani, acceleration, distance over time is acceleration now, you see. Right, distance over time is speed, right? So meaning to say, if I have a gradient that looks like this, it has a constant speed. A higher gradient means to say a higher speed, and zero gradient means to say zero speed, right? And of course, if I have a negative gradient, what does negative gradient indicate again, Neonica? Would you happen to remember?
I wasn't there for this class.
Sorry?
I wasn't there for this class.
Oh, okay. But anyways, the negative gradient indicates that it is moving backwards, guys, which makes sense, right? Because if let's say I were to put numbers here, let's say this is 5, then this is like, then it's like 10, and then this is 0, right? This guy here, he started walking from position 0 to position 5 to position 10, stayed at position 10, and then move back to position 0. So from here, I know that he is moving backwards in the distance time graph. What about the area under the graph? Does the area under the graph represent anything in the distance time graph? No, it does not. Why? Because area is base times height, right? This base times height is going to be distance times time, right? Which is no formula here. So in the distance time graph, the area represents nothing. It's useless, right? But yeah, thank you. But in a velocity time graph, this would be a different story, right? If I have a velocity time graph here, okay. Velocity time graph here, right? The gradient and the area is going to represent different things. Starting off with the gradient. What does the gradient represent in the velocity time graph? Good, you got it right this time. The gradient is going to represent acceleration, positive gradient, positive acceleration, zero gradient, zero acceleration, and negative gradient, negative acceleration, which is in other words known as deceleration. Very important, right? And from here, what about the area under the graph? Lucas, what does the area under the graph represent in the velocity time graph again?
Distance.
Good. It is the distance traveled by the object, right? From here, these are the important information that you should know for the graphs. In a distance time graph, the gradient represents the speed, the area represents nada. In a velocity time graph or speed time graph, the gradient represents the acceleration and the area represents the total distance traveled. This is very important. Then finally, before we end the day, we learned about air resistance, right? How is air resistance related to speed again? Amazing. The faster the speed, the more air resistance, or the faster the speed, the lower the air resistance?
Faster than more.
Yes, faster speed means more air resistance, which means to say they are directly proportional, right? Which makes sense, right? Because when you start running them fast, you can feel the wind in your hair, right? And that is because there is more and more air resistance acting on you, right? From here, we understand that if an object is falling with air resistance, as it falls faster and faster and faster and faster here, the air resistance is also going to become more and more, right? All the way until the total air resistance upwards is equals to the total weight downwards. When the air resistance is equals to the weight downwards, what do we call this phenomena again, Lucas? Terminal what, Lucas? Wait, Lucas.
Yes.
Do we know what? So we know what?
What?
Yes, very good, Lucas. It's called terminal velocity. Wait, terminal velocity, I remember or not? Terminal velocity is when the upward force is equal to the downward force. It cannot gain any more velocity. It's like terminal illness, right? That's it already. It will not accelerate anymore, right? Terminal velocity, okay, guys. Remember this. And if there's no air resistance, what's going to happen is because gravity is the only thing that acts upon it, that's why it's going to increase faster and faster and faster and faster, right? This was chapter 1 for the whole motion time graph part. Then after that, chapter 2, we combine mass and weight already, right? What's the difference between mass and weight? If we define mass, it is the amount of what in your body again? Yes, because you matter, right? Right, so it's the amount of matter in your body. And because it is the amount of matter in your body, will it change if you go to different gravities? No, it will not change, guys, because matter, unless an alien bites off your hand, the amount of matter in your body is not going to change, right? Mass is measured in kg, guys. Weight, however, is going to change, right, according to your gravity, because weight's formula is W equals to
M times G.
Mass times gravity. Excellent, right? Because of this, if you go to different planets with different gravities, what's going to happen is the weight is going to change accordingly. So obviously it's going to change, and weight is always measured in newtons. Excellent. These are the information you should know. And finally, we talked about density. Density's formula is rho is equals to mass over volume, guys. By definition, density is the amount of matter per unit volume, right? And because of this, an increase in mass is obviously going to cause the density to increase, and an increase in volume is going to cause the density to decrease, because they are inversely proportional to each other. Yeah, and that's all the information you need to know, right? So having said that, you see the exercise that I've given you. I want you guys to complete the first 4 questions right now, and then we'll discuss the answers immediately. Do right. You have 8 minutes to do the first 4 questions. Okay, done. The first 4 questions. You guys online done? You guys online done? Was it 8 minutes already? What time are you in? Yeah, I walk out.
I need to
Shit.
see the time.
I forgot to look at the time. Okay, let's assume everyone is done now. Since you all are nodding in silence, I know. Are you done? Okay, anyways, moving on. Right, so what's the first question here? They say that the velocity of an object increases from 30 meters per second to 50 meters per second. So what's this piece of information here? Your initial velocity, and this is obviously going to be your final velocity, right? And this is the time taken, they ask about average acceleration, right? So you write the formula A equals to B minus U over T, and you substitute 50 minus 30 divided by 5, which is ultimately going to lead you to C here. So the first question is C. Congratulations, you got your first free mark. Then after that, the next question here, they say that a heavy metal ball falls vertically downwards through air past 4 equally spaced levels, J, K, L, and N, J, K, L, and N here, right? The time taken to fall from one level to the next is measured. Okay, so there's time taken to measure here. Where is the speed of the ball greatest and which time is the shortest here? Now, if you think about it, right, if this metal ball is falling downwards here, it is obviously affected by gravity. Right, it's affected by gravity. Yeah, there's going to be air resistance now, but which one do you think will have the greatest speed between J, K, K, L, or L, M? Why?
First, it would increase.
Yeah, because gravity is a form of acceleration, right? As it falls lower and lower and lower, the speed of the object is going to accelerate faster and faster. And the speed of the object is going to increase more and more and more because of acceleration. So obviously, the shortest time is going to be Lm as well, right? And thus, your answer could be no other than donkey here. Make sense? Do you get this correct? Which one do you circle? What? How did that make sense? Right. Then fine. The next part here, 4 objects are moving along a straight line. The distance of an object from a fixed point on the line is plotted against time. Which object is decelerating? Now, if I look at these graphs here, all these are distance time graphs, right? Just now I mentioned that in the distance time graph, the gradient represents the speed only, right? How do I find out which one is actually decelerating? Which graph do you circle? YC. What does this mean? This like that. What does this mean? How do you know that? Explain it in terms of the gradient.
The gradient is decreasing.
Good, very good. You're supposed to choose two specific points. And you will find here that this gradient is like this, and this gradient is like this, right? This gradient is like this, right? You'll notice that the gradient here is higher, the gradient here is lower. If the gradient is decreasing, it means to say the speed is decreasing, which is a form of deceleration. So this is the answer. Excellent job. All right. And finally, the last part here. A brass ball and feather are released at the same time. On Earth, the ball reaches the ground first, obviously, right? But on the moon, they reach the ground at the same time. What is this explanation? Why will they reach the ground at the same time?
No air resistance.
Good. It's like the video that I showed you guys, right? Because there is no air resistance. Once there is no air resistance, the only thing that is pulling them downwards is gravity, and both of them will be acted upon by the same gravity, and thus they will have the exact same landing time. Okay. Do question 1 to 3. It's going to be a little bit tougher this one because it's a paper 4 question, but I'm sure you all will manage. All right, let's take like 10 minutes, 15 minutes to do this. Yeah, let's do it in 15 minutes. Let's go. It's time to write down the time so that we remember. Okay, 8.13. After I run with this, we'll take the last half an hour to throw some eggs down.
There.
Yeah, because you wouldn't want to have some eggs land on the cards, right? Okay, once we're done with this, we'll start doing the X-ray. We'll start doing the X-ray. Okay, let me get ready to start. No. No. For sure no, bro. It's from time. Are you done, Macy? Are you guys online done? Okay, let's go through the questions. Boys and girls. Okay, if you look at the first question here, a rocket is stationary on the launch pad. At time equals 0, the rocket engines are switched on and exhaust gases are ejected from the nozzle of the engine. The rocket accelerates upwards. Figure 1.1 shows an acceleration of the rocket varies between time equals 0 versus time equals t. Now, if you look at this first part of the graph, guys, you'll notice that this is actually a very special graph because it is an acceleration time graph. If it is an acceleration time graph, this means to say this here is increasing acceleration, and then here is constant acceleration, right? First things first is they ask you to define acceleration. Acceleration is the change in velocity over time, right? Change in velocity, the rate of change in velocity. Now, guys, if you remember the formula, A equals to V minus U over T, right? the rate of change in velocity means to say the change in velocity over time. In your exams, if you ever see the word rate, right, guys, if you ever see the word rate, it means to say there is something over time, like speed is distance over time, right? I could say the speed is the rate of change in distance, or velocity is displacement over time, right? I could say that velocity is the rate of change of displacement. Whenever you see the word rate, it's something over time. Okay, so from here, my answer would have been the rate of change in velocity. Or you could have written like an increase, and you could have written something else, an increase in velocity over time, or anything along the lines. You could say the increasing speed over time, or whatever that defines acceleration. Okay, doesn't matter. Then the next part here on figure 1.2, sketch a graph to show how the speed of the rocket varies between time equals to 0 and time equals to 0. If today, right, I understand that there is an increase in acceleration now, do you think this is correct? If I draw like a straight line upwards? No. How should the graph look like instead?
I don't like it.
Like this, like this, is it?
Until there.
Okay, until here. This is not right.
Okay.
Why? In the speed time graph, right, which component represents the acceleration? In a speed time graph,
Nothing.
what do you mean? Nothing. The gradient represents the acceleration. Right now, looking at this graph here, if I have increasing acceleration, shouldn't I have increasing gradient? And this graph here is a decreasing gradient, isn't it? Yes, it should be curving upwards instead, meaning to say the graph should look something like this instead, right? I mean, all the way until here. Then after that, sorry, you see, this let's assume that this is the line. I mean, if you use a ruler, it will be much better. Initially, it was increasing acceleration. Then after that, it was constant acceleration. Means to say the graph should look something like this. Because in a speed time graph, if the gradient is constant, it means to say the acceleration is constant as well. But this, it's like diagonal. It's diagonally upwards because the speed is still increasing, right? With constant acceleration, constant gradient here, increasing gradient here. Because increasing acceleration, constant acceleration here. It should be like going upwards, because the speed is still increasing. Of course, you draw until here, but you didn't draw it with ruler. Okay. Then after that, the next question. Now look at this next question here. Yet again, it is a speed time graph. This time is in km per hour, and this is in minutes. So I know for a fact that I have to change this into minutes, or I have to change this into hours. Either one, right? And it says that a bus is traveling between point A and B. There are buses A, B, C, and D, but the buses do not stop at B and C. Figure 1.1 shows the speed time graph of the bus. Okay. Then after that, they say, describe the motion of the bus between each of the bus stops. Select the appropriate description from the list. Okay, between A and B. This here is, what's this part called? Which one do you think it is? You have constant acceleration, decreasing acceleration, increasing, moving backwards, moving forward, or stationary. Which one do you pick for A and B?
B.
Good. This one here is decreasing acceleration for sure, right? Because you can see that the gradient is slowly decreasing for the first part. Then the next part, B to C. This one here is obviously, no. How can it be stationary? Yeah, it is moving forward with a constant speed, right? Because you see that it won't be stationary because the speed is constantly at 40 kilometers per hour. So this is going to be your second answer. It is moving forward with a constant speed. Moving forward with a constant speed. Right, and then finally, this last part here, C to donkey, is supposed to be deceleration, right? But you notice that in these selections here, there's no one thing that is deceleration. So which one is the closest one to this part already? Decreasing acceleration, no. Decreasing acceleration is used already. No. Which one do you think it is? Can it be this one? Moving backwards? Possible? No. Stationary? No. This one no. This one no. Increasing acceleration? No. Why is it constant acceleration? Because this is a straight line. Yes, very good. If it is a straight line, yet again, it means to say it has a constant deceleration. In this case, here is constant negative acceleration. It's constant acceleration here, right? And this is the way you're supposed to answer these questions, guys. All right. Then moving on to the next part here, the average speed of the bus between A and B is 23 kilometers per hour. Calculate the distance between A and B. Now, if I see the word average speed, I know speed's formula is distance over time, right? If I have average speed, it basically is supposed to be, still remember, total distance over total time, right? So right now they want me to calculate the distance, right, which is going to be this. I need to find out how much is the total time. Looking at the total time here, 2 seconds your head, this is 2 minutes. So 2 minutes, can I just straight away go like average speed times total time is equals to total distance? Can I do that? No, I have to convert the minutes into hours, right? Because this 23 is in km per hour. I need to multiply it with the total time, which is also in hour. 2 minutes is how many hours? Is essentially 2 divided by 60 hours, right? So you press this in the calculator, you'll get something like
0.7.
0.7. Oh, for 46 divided by 60, which is going to be 0. How much?
767.
767. What's the units here? Yeah, km. Supposed to be in km here. Okay. And the last part here, the bus stops at D for 1 minute and travels at a constant acceleration for 30 seconds. On figure 1.1, sketch a possible graph for this additional motion. Label it X. Right. X when it starts accelerating and Y when 30 seconds later. So the information here is it's stopped for 1 minute, right? If it stops for 1 minute, then this is it, right? Because it didn't move, it stopped, right? No speed. Then after that, the next part here is said they had constant acceleration for 30 seconds. Constant acceleration means to say it's something like this. One straight line upwards. Right? It should not be curved. It should be one straight line upwards. And where do they label X and Y? Label X when it starts accelerating and Y. Start accelerating X here. Y when it stops accelerating here. This is how you're supposed to draw a graph for the last part. Higher. You can draw higher, but don't pass this 30 seconds. Just don't pass the 30 seconds. You can draw however high also can. Draw all the way until here also can. All the way here also can. But it doesn't matter. Just that it must be one straight line going all the way until 30 seconds. Okay? All right, and then the final part here, describe the motion between Q and R. Between Q and R, you notice that this is a distance time graph. Means to say the gradient is supposed to represent your speed. If I have a constant gradient here, it means to say I have constant speed. Very good. Moving with constant speed is acceptable, but the keyword is it must have the constant speed inside. And R to S, you notice that the gradient starts to slope already. It starts to curve. Good. Because it has a decreasing gradient, it will have decreasing speed. And finally, S to T, zero gradient means to say zero speed, right? So you can either say stop, or you could just say zero speed, or anything along the lines is definitely acceptable. Okay. And the final part here, they ask you to calculate the speed between U and V. U and V is going to be this one here. In order to calculate the speed, I must be given the distance, I must give given the time, right? So the total distance here would have been 600 minus 440, right? It will be 600 minus 440, which is 160. And then you divide by the total time, which was here to here, right? 100 seconds on, right? So your speed would have been 1.6 meters per second. It's essentially 160 divided by 100. This meters, this is seconds here, right? Speed equals to there. And finally, last part here, after point B, the straight road continues down a steep hill. The cyclist travels down the steep hill. He does not apply the brakes and all resistive forces can be ignored. Sketch the possible motion of V. If there's no resistive forces and it's a deep slope, that means to say the speed is going to increase or decrease. It's going to increase, so we're going to draw a curved line like this here.
Oh, that's correct.
Yeah. If not, if you only drew a straight line, you basically say that it's moving at constant speed. It must curve upwards, increasing gradient, increasing speed. Always remember that. Okay. Yeah, and that's essentially all the things you should do for this part here. Now, guys, for those who are online, you can continue doing the rest of this. For you, it will be homework. We'll discuss the answers next week. Oh, we're going to start doing the experiment already, guys. For those who are online, you can just continue doing it. We'll discuss the answers. I'll tilt the camera a little bit more towards us so you can see what we're going to be doing later on. Here. Okay, so before I tilt the camera, let me just explain what we're going to be doing. So basically today, in the classroom, we're going to be doing a little air resistance experiment. Okay, the idea is very simple. We're going to stand from the second floor. We're going to start throwing eggs down. Of course, we're not just going to throw eggs down, right? We're going to put the eggs into a parachute. Right? We're going to use the cup as a holder for the egg. I'm going to tie some strings to this cup here. Right? We're going to tie some strings to the cup here. I'm going to use a plastic bag as the parachute, and with a specific design, hopefully the air resistance when we throw it down the building is going to be relatively higher than the downward force, and thus it will save the egg from smashing the 1,000 pieces. If not, somebody's car is going to be smashed. Okay, but you get the idea? Let's start doing it right now. Okay, so here is going to be your car. I'm going to try to do it without the plastic bags in the cup, okay? Oh, that's why you must design and see. You can try your very best to make your parachute as good as possible. Here, you have this whole bunch, and here, don't cut yourself up. Be careful when you do it. And here, there's going to be some strings. I'm going to do one so. Right. Open it up. Oh, so you have more parachute to use. I tell you where I bought this, right? They told me it was a small size one or what.
Why did you not find the egg?
I don't know, they just didn't have it.
I think you got the different there, right?
Ah, oh, okay, I bought it yesterday.
Oh,
Yeah, now it's huge. Cut it out, all the whole thing out, cut it, bro. Another thing. Okay. Actually, it's on. Yes. On paper. Yeah, these were paper for my classes and my students wasted. Should be sure. Still solving the fucking back issue. Use your creativity, help yourself. Oh, don't worry, it's 2 cards.
Right, I have no idea why you.
Ah, perfect. You might lie, huh? You see that? Perfect. Landing. Oh, my. I'm ready. You take your time, and you really, you scroll it down. Maybe this will look better. But the idea is you want to have more area. If you want to have more area resistance, you should have more surface area.
You really just want to pull out there.
I'm ready.
You're not going to see it.
Huh? You ready or not? Are you done?
I think I'll wait. Sorry. Okay.
Do a trial drop first.
Okay.
So gonna smash them.
Just a $100.
Hey, you can't break a few, sorry, you can't make a few omelets with breaking this day. This is a smiley people. Step number one. Humpty is gonna have a new big form.
Hey, put it in drop on the side on this paper.
Yeah, we're going to pick it up by the way.
You know, you find it a lot of people.
Yeah, but sadly, it's just me and you, buddy. So who's having Okay, let's go to the other room. Oh guys, we're gonna go through some mates.
One way a week.
Oh.
Tomorrow.
Humpty Dumpty didn't make it. There's not one all where all the full length. Yeah, for you, you have to drop it a few times. Oh my God. Okay, yeah, guys, that'll be it for today. Please finish up the rest of your homework, then we'll discuss the answers next week, guys. That's gonna be it for today. Then next week when we come back, we're gonna move on to the new chapter already. We're gonna move on to the fourth chapter after we're done with the discussions. All right, guys. Okay, then.
Thank you, sir.
All right, bye-bye.